Hi everyone, and welcome to the BGP Masterclass. Let me ask you a question. When you open a browser and type www.google.com, or when you start a video call with a friend on the other side of the ocean, how does the data actually get there? You might think of the internet as one giant seamless cloud, but in reality, it's not. The internet is actually a massive collection of thousands of separate, independent networks that agree to talk to each other. And the language they use to talk? That's BGP, the Border Gateway Protocol. If you are a network engineer, learning BGP is like learning how to navigate the highways of the world rather than just the streets of your neighborhood. It is the only protocol that truly runs the internet. Before we start, I want to tell you how this series is going to work. This is not going to be a 5-minute crash course. BGP is too complex and too important for shortcuts. We are going to take a slow-pace approach. We will move gradually, step by step. We will start with the absolute simplest configuration possible, and we will build on it in every single episode. By the end of this series, you will be building complex architectures that you would see in a large service provider network or on the CCIE exam. We will use Cisco CML for all our labs, so if you have it installed, you can follow along with me. But even if you don't, you will learn the logic just by watching. So, let's start with the most important concept, the building block of BGP. It is called the Autonomous System, or AS. Imagine a university campus. Inside that campus, the IT administrators have full control. They choose the IP addresses, they choose whether to run OSPF or EIGRP, and they set the security rules. It is their kingdom. They are autonomous. Now, imagine an internet service provider like AT&T or Verizon. They also have their own kingdom. They have their own routers and their own internal rules. In the world of BGP, each of these independent kingdoms is an autonomous system. The problem is, how does a user in the university kingdom send an email to a user in the ISP kingdom? These two networks don't know anything about each other's internal maps. They need a diplomat. They need a standard way to exchange information without revealing all their internal secrets. That is exactly what BGP does. It connects these autonomous systems together. Now, if these systems are going to talk to each other, they need names. Or rather, they need numbers. Every autonomous system on the internet is assigned a unique identifier called an ASN, Autonomous System Number. Think of it like a license plate or a passport number for a network. When you configure a Cisco router, the very first thing you type is router BGP, followed by this number. There is one detail you need to remember for our labs. Just like we have private IP addresses, like 192.168.x.x, that you can use freely at home, we also have private AS numbers. The classic 16-bit range goes from 1 to 65,535. The numbers from 1 to 64,511 are public. You cannot just pick one and use it on the internet. You have to buy it from a registry like RIPE or ARIN. For example, Google uses AS 15,169, but the range from 64,512 to 65,535 is private. You can use these numbers freely inside your own organization or for lab environments. In this course, we are going to use AS 65,000 for our main network. Why? Because it's a private number and it's safe to use. But for the simulated internet providers in our lab, we will use numbers like 100, 200, or 300 to pretend they are real public networks. Now that we understand the concept of autonomous systems, let's look at where we will be spending most of our time. This is our lab topology. I've designed this specifically for this course to simulate a real service provider network. It might look complex right now, but we are going to break it down into 3 logical sections. First, right here in the center, we have AS 65,000. This is our network. This is the autonomous system we control. R1 and R2 at the top are our border routers. They are the gateways to the outside world. R3 and R4 at the bottom are our core routers. Later in the course, they will act as route reflectors, which is a critical design pattern in large networks. Right now, inside this group of 4 routers, we are running OSPF, so R1 can talk to R4 and R2 can talk to R3 using their internal IP addresses. But they have no idea how to reach anything outside of this group. Up here, above the dotted line, represents the Internet. R5 represents ISP number 1, AS100. R6 represents ISP number 2, AS200. And this router in the middle, R7, represents an Internet exchange point, AS300. Having multiple connections like this allows us to test advanced scenarios. For example, if the link to ISP1 fails, how fast can BGP switch traffic to ISP2? Or how can we tell the Internet that we prefer incoming traffic via ISP1, but outgoing traffic via ISP2? We will test all of that. And finally, down here, we have our customers. R8 is Customer A, a simple business with one connection. R9 and R10 are Customer B. Notice that Customer B has 2 locations, a headquarters and a branch office. This setup is crucial because it allows us to learn MPL SVPNS and solve problems where a customer tries to use our backbone to connect their 2 offices together. One last technical detail before we wrap up. BGP is unique among routing protocols. Protocols like OSPF or EIGRP shout out, "Hello packets to everyone on the link," multicast. They are chatty. BGP is different. BGP is polite. It uses TCP, specifically TCP port 179. This means that before 2 routers can exchange a single route, they must establish a standard TCP connection, just like your web browser connects to a web server. This makes BGP reliable, but it also means we have to configure the neighbors manually. They won't discover each other automatically. So, the stage is set. We have our AS65000. We have the Internet waiting for us, and we have the theory. Right now, our routers are isolated. R1 cannot ping R5's loopback. The handshake hasn't happened yet. In the next episode, we will open the CLI. We will configure our very first eBGP session between Router 1 and ISP1, and we will watch that TCP connection come alive. Make sure to subscribe so you don't miss it. I'll see you in part 2.